Let h of x be this integral. We want to see what value of x is h of x a relative minimum. For that, we have to take the derivative. So when we take the derivative, what we're really doing is just plugging in x in for t. So we have negative 4 times the quantity x minus 2 squared plus 8. Now we have to find the critical point, so we're going to set this equal to 0. Expand the x minus 2 squared, and then distribute the negative 4, and then add 8. At this point, we're going to divide both sides by negative 4. And so we reduce this to a quadratic of x squared minus 4x plus 2 equals 0. We have to use a quadratic formula for this, and we end up with 2 plus or minus the square root of 2. So these are going to be our critical points, and here they are in decimal approximation. So we found the derivative, we found our critical points. Now we have to use a number line to test whether f prime is positive or negative. So a nice little shortcut here is we know that the first derivative is a parabola that's upside down. The vertex is 2 comma 8. So the nice thing is this is in vertex notation here, or vertex form. And the zeros that we found for it were at 0.58579 and 3.4142. So we know it's going to look something like this. Basically, to the left of the 0, we know it's going to be negative. Between the two zeros, it's positive. And to the right of the last 0 is negative. So this is a nice way to do it without actually plugging values in. So now, if f prime is negative, that means our function is decreasing. If it's positive, it's increasing. At 0.58579, we have a relative minimum. And then at 3.4142, we have a relative maximum.